You have said it before. I know what I need to do. I just can't get it into code. Let me tell you what's actually happening. You're not stuck on the code, you're stuck on the words. If you can't say it in English, you don't have the logic yet. The code is the not hard part, the description is. The method is simple. One sentence, one step, one line of the code. Let's practice that with 15 problems, starting from zero, all beginner level. In problem 1, we have fizz and buzz. So here the goal is to count from 1 to n and replace the multiples of 3 with fizz, multiples of 5 with buzz, and multiples of both with fizz and buzz. And if it's not multiple of any one of them, then give the number itself. Here we can see the example. Step 1, we have to start counting numbers from 1 and upwards. Step 2, we will check if the number is divisible by 3 and 5 both. If it is, then print FizzBuzz. Step 3, if it's not divisible in the second step, then we will check is it divisible by 3 only. If it is, then print Fizz. In step 4, if it's not divisible by 3 also, we will check if it's divisible by 5 only. And if it is, print Buzz. And if the number is not uh, able to satisfy any of the above conditions, print the number itself. It's easy. Problem 2. Find the largest. Here, the goal is to find the single highest number in an unsorted list. Here we can see the example. Step 1. Look at the first item. Assume it is the largest. Step 2 is to walk through each items which are remaining in the list. While going through the item, we have to check is the current item bigger than the number we have assumed at the first step. Then we have, if it is the largest, then it will become the new assumed largest. And we have to do this until the list is finished. And the last assumed value is the final answer. Problem 3. Reverse a string. Here, goal is to take a word and return it spelled completely backwards. Here we can see the example. Step 1 is to carry an empty space for the reverse word where we can store it. Then we'll have to start at the very last character of the original word and copy that character into the new space. Then in the next step, we will move one step left and repeat the same. And by the end of it, we will have the final list completed, which will be the output. Problem 4. Even or odd. Here, the goal is to determine whether the given number is even or odd. Here we can see the example. Step 1 is to take the given number, divide it by 2, then check is there a remainder left over. If there is no remainder left, then we can say the number is even. And if the remainder is 1, then the number will be odd. Problem 5. Here we have to do sum of all the numbers from 1 to n. Here we can see the example. Step 1. We have to start a running total at 0 and a counter at 1. Then we have to add the counter to the running total. Increase the counter by 1. Is the counter now greater than n? If no, then stop. And if yes, the running total is the answer. Problem 6. Count vowels. Here, the goal is to count how many vowels, which are A, E, I, O, U, exist inside a given word. Here, we can see the example. So, first step is to set a tally to 0. We will take a variable which we will initialize to 0 so that we can have a counter. Step 2 is look at each letter of the word one by one and check if the letter is either a vowel. If yes, then add 1 to the tally. If no, then skip it and repeat it until all the words are finished. And by doing this, at the last, we will have the number of total vowels in the tally. Problem 7. Find the minimum. Here the goal is to find the single lowest number in an unsorted list. Here we can see the example. So first step is to look at the very first item in the list and assume it is the smallest number. Walk through each remaining item and check is the current item smaller than the number which we have assumed minimum at the first step. If it is smaller, then it will become the new assumed minimum. And we have to finish the list and the last assumed value is the answer. Problem 8. Calculate the average. Here the goal is to calculate the mathematical mean of a list of numbers. Here we can see the example. So the mean is calculated by the sum of all the numbers in a list divided by the total number of items present in the list or the total numbers present in the list. Here we can see in the example. So first we have to set a running total to 0 and a count to 0. Then we have to check for each number, add it to the total and increment the count by 1. Then after all the numbers are processed, divide the total by the count. And by doing this, the result will be the average of the particular given list. Problem 9. Power of 2. Here, the goal is to check if a given number is a power of 2, that is 1, 2, 4, 8, 16, and so on. Here we can see the example. Given 8, 8 can be written as 2 into 2 into 2, which is 2 raised to the power 3, and it is given as yes. 6, where in the place is not related to any of the power 2 number, so there the output is no. Step 1 is if the number is less than 1, then it's not a power of 2. So we will stop right there. Step 2, if the number is bigger than 1, then we'll divide the number by 2. Does the division leave a fraction? If it is, then not a power of 2, and we have to stop. If the result is exactly 1, then yes, it is a power of 2. If the result is greater than 1, then the repeat from step 2. And at the last, we will get our answer. Problem 10. Celsius to Fahrenheit. Here the goal is to convert a temperature from Celsius scale to its Fahrenheit equivalent. Here we can see the input is 100 degree Celsius and the output is 100 into 1.8 plus 32, which is 220. 12 Fahrenheit. So first we have to take the temperature which is in Celsius. Then step 2 is we have to multiply it by 1.8 and then add 32 which we have given at the step 2. At the last we will get the final number which is in the Fahrenheit. Problem 11. String length. Here we have to count the exact number of characters in a given list. In the example we can see the input string is code and we can see it consists 4 individual characters which is CODE. So step 1 is to set a counter to 0. Then look at the string. For every character you see, add 1 to the counter. Stop when there are no character left. And at the last, the counter holds the length of the string. Problem 12. Palindrome check. Here we have to check if a word reads the same forward and backwards. Here we can see the race car, if it's reversed, it's still a race cars. Whereas hello, if it's reversed, it's not hello again. So it's not a palindrome. So first we have to compare the first and the last character. Do they match? If not, then we have to stop. It's not a palindrome. Move inward. Compare the second to the second last word. Not word, but character. Keep comparing inward pairs until you reach the middle. No mismatch found. It is a palindrome. Problem 13. Sum of a list. Here, the goal is to add up every number contained in a given list. Here we can see in the example. So first we have to start a bucket running total at 0. Then we have to take the first number from the list and add it to the bucket. Then take the next number and add it and continue this step until the list is empty. And at the end, when the list is empty, the bucket holds the final sum. Problem 14. Linear search. Find if a specific target exists within an unsorted list and return its position. Here we can see the example. Find 7 in the list, and here we can see the 7 is at second index. Step 1. Start at the very beginning of the list. Then, is the current number the one we are looking for? If it is, then stop and return the index. If no, then move to the next item and repeat. Reach the end without a match, it means the number does not exist. Problem 15. Here the goal is to generate the first 10 multiples of a given base number n. Here we can see the example where n is equals to 4 and we have to generate the first 10 multiples of a given number. So step 1, we have to choose our base number, which is n. Set a multiplier at 1 and calculate n into multiplier and write it down. Then increase the multiplier by 1 and repeat this until the multiplier exceeds the 10. And at the last, we will have all the multipliers of the given number from 1 to 10. Every solution above fits in one plain sentence. The code is just the translation. You were never missing the logic, you were skipping the words. Describe it first, then write it. The keyboard comes last. Practice these problems and try to implement similar approach while solving any of the given problem.